So welcome to the session on the improvements in BricsCAD V23 for surveyors and civil engineers. We're going to focus today on key workflows to showcase how much this release has to offer these industries. We will also run many more presentations following on from this and look forward to all feedback and suggestions. My name is Sean Toomey. I'm a senior solutions consultant with BricsCAD based in Sydney, Australia. My background is in civil engineering, GIS, and surveying, and I've got over 20 years' experience in the extended CAD BIM spaces. So, before we look at the agenda, I would like to thank Veris from Australia for giving us the data set for this presentation. Veris is an industry leader that we enjoy working very closely with. They have 15 offices around Australia with expertise in all facets of spatial data services, including, in this case, laser survey. And the point cloud we're using has over 4 kilometers of roads and contains over 400 million points. So it's an ideal data set for us to work on. In terms of the agenda, we're not going to go through all the new features in the software or all the new picks and clicks. Instead, we're focusing on workflows. And these are based off discussions with customers on real challenges that they've been experiencing. So the first of these is the challenge of efficiently working with large point clouds. And by efficiently, we're referring to the need to generate thin surfaces that are simplified for practical purposes, but also detailed enough for design purposes. So we'll go through this in some detail. We will then look at how we can now interact with GIS data sources and ultimately link this to a visualization in Twinmotion. And the last workflow is to do with importing external designs. Now we'll do this early in our design process and then manage how we incorporate updates and variations of these into our project workflow without having to redo all of our documentation steps. So all of these will be showcased with the improvements in the new user interface and user experience. So one of the main features of this is the new Civil Explorer. In here, we can access the general hierarchy and also all the commands and settings of the civil objects. As well as this, we also have a new civil workspace on V23. Civil and survey work, it's obviously done in 3D, but we understand that the documentation process involves construction notes and details in 2D. So these are done with traditional drafting tools. And with this in mind, we now have a civil design workspace on the launcher. This will provide a 3D and a 2D documentation toolset in the interface. So surveyors and civil engineers are set up to become productive straight away. So let's begin with the first workflow, which is point clouds. As we mentioned, our challenge here is to manage the number of points imported into the tin to have relevant detail in relevant areas. So in this case, we're looking at an existing intersection. And we want to investigate an option to position a roundabout and work out the logistics. So for this, we need to establish accurate detail on these 4 traffic islands and work out how we're going to work through that. That's our first example. Then we will look at extending the car park on an existing road. And for this, we need to model the curve geometry accurately. And this is so that the saw cut line is established and projected in the correct area with the correct detail. So let's open the software and take a look at the full point cloud to begin with. So let's open the software and take a look at the full point cloud to begin with. So when we select this point cloud, we can see that the original version has got over 400 million points in it. We can also hover over it and bring up the new dialog for the point cloud color map, where we can change the stylization to intensities or to elevations, and then change the color scheme to, for example, spectrum to clearly show the height differences across different points. In our case, we're concerned mainly with the ground points, so we will leave it at scan and close this and point out the fact that our challenge here is that we got loads of detail of the road points and the curb and gutter and the footpath, etc. But as we zoom out, we can also see a lot of detail of these overhead power cables, poles, trees, etc. So we've got lots of points that don't represent the topography of the ground surface. So since our friends at Leica are also under Hexagon Geosystems, we were able to work together with these guys to achieve the following. So this is the same point cloud where we filtered out the poles and everything else, just showing the ground points. We've also snipped it slightly. So this point cloud has still got 90 million points on it, but it's just the ground points. So our challenge here is to create two surfaces. One is going to be the highly simplified tin, and the other is that same tin with the extra detail added into the traffic islands and road widening area. So since the filtering process of creating tins can take several minutes, we've already made these. So if we look at our Civil Explorer and expand out our tin surfaces area, we can see we got ground surface 1 and ground surface 2. So if I click on ground surface 1 and unhide, I can change my style view to 2D wireframe. And in here we can see that we've got a very, very large triangle spacing. So what we've produced here is a very, very basic topography to show the overall slopes of the surface. We can examine how accurate this is by going to the Visual Styles tab under the Civil Explorer. This produces the option to access all the analysis in one tidy interface for this tin. So I can, for example, turn off my triangles, turn on my contours. Under the contours, I can change my intervals to, let's say, 0.5 and 2.5. Now, this is the same information I would access by going to my properties here. But by doing it through the Civil Explorer, everything is housed together in a very, very easy to access environment. So we could also go in here and, for example, turn on the elevation triangles and quickly show which way the general topography is falling. We will focus mainly on understanding how the triangles were created. So we'll turn off the contours again and turn back on these triangles. And we can see that it's a very, very low density. To understand exactly what that density is, we can click on our statistics tab. And in here, we'll see that the number of points has gone from 90 million down to 2,000. So this is quite extreme. We've done this on purpose just for two reasons. One is to show that it can be done if we need that to happen. Also, we've picked this so that when we redensify, the contrast will be very obvious on which areas have had the extra information applied. So to show how it's been done, if we go to our next tab, which is our definitions tab, we will see here a sequential list of all the steps that were done to create this tin. We could also access this via component, where you would go, for example, straight to the point cloud option. For what we're doing today, doing it sequentially makes more sense. So the first step we did was where we added the point clouds. So if I double click on this, we can see that we've enabled simplification and we've given a radius of 10 meters and an elevation difference of 1 meter. Now, the lower the value, the more accurate the tin surface. So by picking values as high as this, it's obviously going to be a very, very basic overall topography, which can be useful because it's very, very quick. But we definitely need to be aware of the fact that we're simplifying it in a quite extreme way in this case. So we will show the other version next. But before we do, let's look at the last tab, where in here we've typed in the names and descriptions. So it's just good practice to do this in general. Let's go and turn this one off and turn on the redensified version. So in here, we can clearly see that the triangles have been added to these 4 traffic islands, as we specified earlier. To show how that's been done, if we go back to our definitions tab and bring up the same step, we can see that in here, we have enabled the redensify option. And we've basically picked on each of these 4 polylines to add extra information at the difference of 0.1 meter in there. So if you look at this traffic island here, we can see that the overall topography is working off an elevation difference of 1 meter, whereas in here, it's working off the elevation difference of 0.1 of a meter. So this is why we have all that extra information, which is exactly what we're after. We've also added that information to the road widening over here on our left-hand side. So what we can now do is work through these 2 examples that we mentioned. So we've got a alignment here for our general roundabout area. If we hover over that, we get the option to create the profile view. We can then select that profile view and change the vertical exaggeration to a factor of 10 to make it more obvious on how the traffic islands have been added. So let's type in 10 here to the properties, and we can visually see straight away that the traffic island is very, very obvious in terms of how it's being added. We're not going to do too much work on the design, but we'll just do a basic prelim start where we will add an automatic profile design. So we click on automatic here, and we can see that a profile has been added here. If we look at the criteria in the properties, we can see it's automatic, and it's based off a vertical tolerance of 0.1 meters. What this means is that the software will put enough intersection points to make sure that at no point is the design profile any more than 0.1 meters away from the existing ground. So if we change this from 0.1 to 0.5, we now have more tolerance, so there's a lot less IPs. What we could then do is change that from update mode from automatic to manual. And now that it's manual, we can go and grab any one of these PVIs and move them around to get the general basic design that we're after. And we've done it graphically here to begin with. What we can now do is go to the PVI section here and type in a station of, let's say, 15 meters and an elevation of 107.3. We could also go and hover over here and use the quad to add or remove new points. So let's add a new PVI here. Let's also go and remove that one. So you can see how much control we have to get started once we've managed to achieve the accurate levels of detail on our tin surface. So that produces our basic starting point for our roundabout. If we then go and look at our road widening area, we've got the similar situation with the triangles being added. What we've also got is a 2D line of where we wish to start our car park design. So the first thing we'll do is hover the mouse over the tin surface and click on the option to project the tin. So we've got the option here, project the tin surface. Click on that 2D polyline, press enter. We get the option to erase the original line. I'll press yes in this case. And we've now got a 3D polyline draped over our tin surface. What we can do is just take a 3D view of this just to show exactly what we are working on here. If we put this back onto a shaded view, we can clearly illustrate that the tin surface has been generated in a way that the exact shape of the curb and gutter has been taken into account here. So as we build our car park, we're confident that we're working off the exact detail that we needed. I'll put this back onto a 2D wireframe view to make it easier to look at and go back to a plan view. So all we do here is use the grading command. We'll select this 3D polyline and I click on the slope offset option. So on V23, we do have the option to apply different parameters for different ranges along our grading. We'll keep this simple and use the entire length. I will press tab and type in a slope of say -2%, and I'll gradually pick around 4 or 5 meters for my car park. This produces a very basic starting point for our car park extension, but we're happy that we've done it with the exact saw cut line that we've needed. So these are just two examples that we've chosen to illustrate how much control we have with the simplification and redensification process. We can do a whole bunch more of these, but in the interest of time, let's go back and look at how we work with GIS data. So we're going to work with two external data types in this presentation. The first is underground services being imported from Esri shapefiles. And we know these as the industry standard, and we can now import and export large data sets complete with attributes. So we'll go through the process of assigning elevations to the geometry and creating solid objects for visualization, both in BricsCAD and for exporting to other packages such as Twinmotion. So let's bring back up the software and go through this process. So the first thing to point out is that we've got layers already for these different services. So we've got various line types assigned to these for electricity, sewer, water, etc. And all we have to do to import the GIS is go to the ribbon, click on GIS Import, grab these Esri shapefiles and press Open. So the geometry comes across. We will spend a little bit of time making sure that we apply the correct BricsCAD layer to the correct GIS layer. So we'll click on the sewer option and make sure we click on the sewer area. We could specify the import area in terms of polygons, but we don't need to for this example. We bring across everything, and we can see that the geometry has come across. More importantly, if you click on any of these lines and go to the properties, you will see that the material, diameter, and all other attributes that were stored in that shapefile have come across. So we could edit these. We can also edit the geometry and then go back up and re-export these. So it's a very, very intuitive and powerful process that works across large data sets. To keep things interesting, what we'll do here is a similar process to how we worked with the string on the car parking area in the previous example. We will hover the mouse over the twin surface and again click on the project option. We just pick one of these lines and press enter. Again, I'll pick the option to erase the original geometry, and what we now have is a 3D line that's been draped over our surface. So if I go and take an orbited view of this, I can see exactly what's happened. What I'll now do is use the manipulator. Let's hold over this and lower this by the depth that we read from our attributes, which is 1.2. Let's type in 1.2 here. So to generate the 3D object, I'm going to do a circle and give it a radius of 0.15. We will use a sweep command, select that circle, and then click on our 3D polyline to generate a swept object of a diameter of 300 millimeters. This gives us the solid object in the correct space based off our twin surface to start doing our visualizations. So if I now go and orbit below this to actually look at it in 3D, I will turn back on my modeling view. We will see that the pipe has been placed in the correct area so that when we export to Twinmotion later on, we'll be able to see exactly where the services are at in terms of doing our logistics for our site designs. So let's now go and move on to the second external data source, which is part of the overall project workflow. So in this project, the general workflow can be represented as we started off working with large point clouds. We then incorporated GIS. We're about to import a simple external land.xml file for a site design. We would then do some prelim design, some detailed design, move on to documentation and collaboration, and if time permitted on the project or budget, we would hopefully do some visualization as well. The challenge we have is that at some stage in the process, we're going to get an updated version of that external land.xml design. This leads to the situation where, in terms of sequential order, when that update arrives, the design and documentation is already in progress based off the first version. So inserting it back into its original position in the workflow involves redoing all those subsequent steps. What we're going to show here is how we can improve on this with the definitions within the Civil Explorer. So let's go and import the land.xml file first. We click on import land.xml. As you can see, we got two versions of the XML site here. Let's open the first one. And we'll just put this onto a different layer. And what we'll also do is we'll change the styles to a 2D wire. To make it even more clear, I will hide my other tin. And within the Civil Explorer, I'll click on this side and turn on contours. Now in here, we can use the new labeling option within V23. Let's click on a contour label. Let's accept default styles, and we put a label down here. After this has been done, we can click on the label and move it around. As we move it, you will see that the labels interact dynamically even before I've finished positioning them. I can also add a spot label using the exact same process. So spot elevation, I'll accept default styles again and put a spot elevation around here somewhere. The exact same process occurs where as I move this, you will see the number updates interactively as I move it around. The next thing we'll do is go and make some edits to the actual triangulation. We can see that in this area here in the north, the triangles have got a few blemishes which are causing the contours to kink around. So if I use the quad, I can click on the smoothen option. I will give a radius of 5 meters, and I can quickly smoothen this general area. I can refine this further by right-clicking on the side on the Civil Explorer and using the new swap edge. As you can see, we can access all of the edits here as well. So when I click on swap edge, I can move this edge, for example, and as it changes orientation, you can see how the contours update again. Now, in our definitions tab, we can follow this progress. We can see that we've imported the XML, we have done some smoothing and done a swap edge. So it's a pretty simplified process, but let's just show how we can go and change our original definition and see how everything updates. So we're going to bring in a new version. I'll position this over to the right-hand side to make some space. I will go to my original import and browse to my new file. And when I press open here, if you watch the contours, you can see a lake has been introduced in the southern part of my site. If I now go and move these labels around, well, first of all, the labels have been maintained, but I can now go and reposition them to make them more appropriate for the line work. I can also see that the label for my spot elevation shows the correct value. Also, the edits I've done to the contours in the northern area have been maintained. So I can go and make this even more obvious by grabbing these edits and temporarily disabling them or re-enabling them afterwards. I could also, of course, delete these, or if it was more complex, I could even change the order. These are reasonably simplified versions, so we don't need to worry about that just now. The really important point to emphasize is that when we make the updates, the labels are maintained and so are the edits. So this is a deliberately simplified version, but clearly illustrates how the updates can be incorporated into the workflow for thin surfaces in BricsCAD. We now want to show how this can be extended for visualization purposes. So we have the ability to connect the BricsCAD drawing to Twinmotion so that when the objects are updated in BricsCAD, we can run the synchronize command and have Twinmotion update like an XREF. And this now works with tin surfaces as well as solid objects. So we've linked the tin we imported from LandXML and the pipes imported from GIS to the Twinmotion file. And we've also imported the point cloud, which is a separate process, to create the full effect. So let's first of all show the Twinmotion scene. So let's first of all show the Twinmotion scene. And we can see the tin we created from the ground surface with the aerial photo imported from BricsCAD. We can also show the point cloud here. So if I turn on the point cloud, we can view that as well. And also we've linked a separate file with the site and the pipes. So the pipes are shown in X-ray mode, meaning that when we view from above, we can see them through the ground surface. And what we've also done here is saved some existing views, which just provide a good perspective of where the site is located. And we now want to repeat the process of updating the definition of the LandXML file import for the tin and show how it synchronizes into Twinmotion. So for simplicity, we've placed these into a separate drawing file here. And what I'm going to do now is the exact same process as the previous steps, where I go to my definitions and I'm going to browse to the second version of that XML file. And we can see that we now have the pond showing up. So I'm going to push this window across to the side here and click on the synchronize button. And when I do this, you can see that it updates inside in Twinmotion. So what we're clearly pointing out here is that we have the ability, in terms of workflows and external data, to extend these beyond BricsCAD while still maintaining the dynamic link. And the potential for this is enormous, and it's something we'll explore in a lot more detail with a series of future webinars with Twinmotion and the full Unreal Engine. And this concludes the 3 workflows we wanted to show you on today's session. So to summarize, we were able to convert the point cloud into a thin surface with flexibility to specify the accuracy of triangulation in relevant areas to build up our initial model. We then imported GIS data, complete with attributes, and used the tin to assign elevations and create solid geometry. And we then showed how we can work with multiple revisions of external files, land XML in this case, while maintaining documentation and edits and even extending it to Twinmotion for visualization. So these are just 3 samples of the amazing potential in the new release. We're looking forward to showcasing a lot more of this, so please make sure to send us in all the ideas and comments, and thank you for your time.